Hello, my name is Robert Hammerschmidt, and I created this application Great Food for my class project in CSE 335. The purpose of the app is to remember certain dishes that the user has ordered at certain restaurants that they want to remember. This is meant to help people who have a hard time remembering what dish they ordered the last time they were at a city or restaurant. Let's say that you visited a city a year ago and had the greatest pasta you've ever had. Over the course of a year, most people would forget the name of the restaurant where it is located at. Even more people would forget the specific name of the pasta they ordered. This app not only provides the user with this information, but will also provide nutritional data of the pasta to make an informed decision before revisiting the restaurant. Now let's see what this looks like. The app will start off in the first view controller where it displays the table of the dishes already added. The table allows for easy scrolling access to all the foods the user has added to the list. It also allows the user to easily delete any dish in the table by simply swiping left on the item and by pressing the delete button. A food is added to the table by simply pressing the add button on the top right part of the screen. Once the add button is pressed, it goes to the add food view controller, where the user can add the name of the dish, the name of the restaurant, the address of the restaurant, a description of the experience, and an image of the dish from the image picker. Once the user is done adding what he or she wants to about the dish, all the user has to do is press the Done button at the top right of the screen to add the dish and go back to the table. If the user didn't want to add an item, all the user would have to do is press the Back button at the top left of the screen. Once a user has added a dish to the table, the user just has to tap the dish to view the details of it in the Detail View controller. The Detail View controller displays all the data saved by the user when he or she added it in the Add View controller. This includes the name of the food, the restaurant name and address, and the picture chosen for the food. It also shows a map with a place marker of the address to better show to the user where the restaurant is located. From here, the user can go back to the table to select another dish by pressing the Back button of the upper left side of the screen, edit the data of the selected food by pressing the Edit button of the top right side of the screen, or view the nutritional information of the selected food by pressing the Nutritional Information button on the bottom left side of the screen. If the user selects the Edit button, it will go to the Edit Food View controller. Here the user can edit any field of data and have it saved, including the image. If the user is satisfied with the changes, he or she can press the Done button at the top right of the screen, which saves the changes and unwinds the original view controller. If the user decided not to make any changes, all he or she would have to do is press the Back button on the top left side of the screen to return to the Detail View controller. If the user selects the Nutritional Information button in the Detail View controller, it will go to the Nutritional View controller. Here a web call gets the total calories and fats the food has and displays it. It also displays the original picture of the food for reference. Once the user is done viewing the nutritional information, he or she can press the Back button at the top left side of the screen to go back to the Detail View controller. Now let's see how this is all done by looking at the app's Unified Modeling Language Diagram. As you can see, every view controller has a view did load and did receive memory warning, which are important to how the app runs but aren't what makes it different from others. So I'll focus on what makes my app different. The app starts at the view controller, so let's start there. Here we have the table view functions, which display all of the food into the table from the all food array, return the count of all food in the table, and delete an item in the table by swiping. We also have the view will appear function that helps update the table with core data. It also has a prepare function that sends all of the data to the food detail view controller. Next, we have the Add Food View controller. Here we have a Choose Picture button function that runs when the Choose Picture button is pressed. This function uses the Image Picker controller to pick an image from the device. Then we have the Done Adding Button function, which runs when the Done button is pressed, which saves all of the data entered into core data. Next, we have the Food Detail View Controller. Here we have variables where the prepare function in the view controller saves its data. We have a function map type selector, which sets the map to the chosen map type. We also have another prepare function to either send the data to edit in the edit food view controller, or the name and image of the food to display and get nutritional information about in the nutritional view controller. Next, we have the edit food view controller. Here we have a fetch record to get the core data and context to edit it. Just like in the add food view controller, we have a choose new picture button and image picker controller functions to pick a picture from the device and save it. We also have a done editing button function, which saves all of the edited information to core data when the done button is pressed. Finally, we have the nutritional view controller. Here we save the name of the selected food to food nutrition name from the prepare function in the detail view controller. From this name, we do a JSON web call to api.nutritionx.com, which sends back the total number of calories and total fat of the food specified. This is all done in the function getJSONData. That's about all there is to the UML diagram. Next, let's go over the model view controller diagram. This diagram gives a more general outlook on what the app does. Here we have the view portion of the MVC. This portion is what the user sees from the app, most notably the map and pictures that are displayed throughout the app. It also displays the table and all of the data that's inside of the table through the view controllers. Next, we have the controller. The controller gets the actions from the view, such as button presses and data entered, and processes it. This includes updating the table with new data entered, sending the data to core data, and setting up the maps and pictures. It also does the JSON web call to get the nutritional information. Lastly, we have the model. The model is what acts as the storage for all of the core data saved in this app. It saves any changes made to core data and sends it to the controller when fetched. That is about it for the MVC diagram. Now, I've already talked about all of my app's capabilities previously, but unfortunately there are two strange limitations to my app that I have discovered. Firstly, I have discovered that if the user does not add a city or specific enough address, the map will display a location that was not originally intended. The user could probably figure this out within 5 seconds, but it is a limitation nonetheless. Also, I have noticed that the NutritionX's API sometimes gets confused with the food entered. For instance, Chili's has the ultimate bacon cheeseburger, but Burger King had a burger named the exact same thing. The API call gave me the nutritional information of Burger King's burger and not the one at Chili's that I was asking for. Although the nutritional information is very similar, it is not as accurate as it could be. As previously mentioned, I use core data instead of cloud storage for my app. This keeps all of the data on the device, but makes it hard to share it with other devices. It saves a lot of time when accessing the data and allows access to the data while offline, excluding the web call for the nutritional information. I should also be saving battery life as well with how my app works. My map only loads when going to the food detail view controller. The web call only runs when going to the nutritional view controller. Also, since my data storage is with core data and not through cloud storage, less battery power should be used in the accessing, editing, and deleting of the data. Throughout this course and this project, I have learned quite a lot about programming in a mobile application environment. I now understand how the MVC architecture impacts the app development process, with how the storyboard interacts with the view controller and how the view controller interacts with core data. I learned how the user experience with an application is the most important thing to think about when developing an app. No one wants to use an app that is slow or flat out just doesn't work. Most of all, though, I learned the severity of planning and time management in the development process. I now understand the many phases that a full app must go through to become complete and how a developer must go about each phase. Although I enjoyed this course and this project, there are a few ways I think there could be improvement. First, I think that having a formal lab section would greatly help students develop their skills, especially since most students don't have much app development knowledge heading into this course. Next, I think it would be helpful to be a little more clear in the class project document by summarizing certain parts and by giving some more examples for students that have less creativity to use. Lastly, although not as big of a deal, I think it would be nice to have a library of known free APIs that we as students could use for our project. I noticed that a lot of students had trouble finding good APIs that would retrieve the information they wanted for their class project. Overall, I thoroughly enjoyed my time in this class and the class project. Thank you for watching.